How are you?
Hey, Jan. I'm good. Thank you. Thanks for inviting me.
Cool. Where are you now?
Right now I'm in Delhi, India.
Oh, cool. All right. I'm in Abu Dhabi. I usually do the live streams from home, but I got like super bored today and decided to get out. My day has been like all meetings back to back. So I'm finally outside into the Rosewood Hotel, sitting in the business center of it, using it from time to time. So what's been new on your end?
All well. So I think recently kind of shifted base to Delhi a couple of months back. So I was based in the Bay Area for a long time, and then decided to move my family to India. So just getting kind of used to this new lifestyle, new country, especially for the kids. But yeah, I think all well on the personal front. On the work side, there's a lot going on. I'm sure we'll kind of talk in this conversation and cover a bunch of that.
Yeah, definitely. I'm actually I'm exposed to like many layer one solutions, and I'm getting more and more excited about ICP. I think this is one of the solutions that definitely like took its time to like get everything built and for people to really start understanding it. But I think 2023 is a very right timing for ICP. So I'm really looking forward to this productive conversation because from my personal experience, ICP has still got like a lot of potential in terms of the exposure and explaining people what it is. And it's one of these blockchains that is unlike anything else, really. And I think it's our mission to get it across to the Web3 community how cool ICP is, and like people may make their own judgments in terms of whether it's good or bad, like whether it's cool or it's nah. But in my opinion, it's definitely a blockchain with a very interesting set of use cases and philosophy behind it. So how would you explain ICP?
Yeah, indeed. I think first of all, totally agree. I think this is one blockchain that has been. So our founder Dominic Williams, if you look at some of his blog posts and like YouTube videos from back in 2014-15, he's been talking about the vision for like internet computer. I think the team has been working on it since 2016, like heads down. So it's been a project that has like seen the test of time. It has taken a lot of time to kind of develop. So roughly, I would say nearly 5 years of like lots of people full time working and building this. So currently, we have a team of close to 300 people based in majority of them based in Zurich, as well as offices in San Francisco and other parts of the world. So yeah, it's certainly a very serious project in terms of like what you would encounter in the crypto blockchain world. So I think what's very unique and different about the internet computer is, as you said, it's a blockchain like no other, right? So the key like idea on how I like to explain this when comparing with like other blockchains is like, if you look at any blockchain, typically what happens on the chain is essentially like it's a ledger which keeps an account of, let's say, Lomesh transferred some tokens to Ian. That's the thing that essentially gets recorded on chain. So it is essentially keeps a ledger of the account transfers. Now you can obviously pack in very small amount of data, like some NFT metadata and so on, can essentially be still written as a part of the chain itself. But like even as simple as basic things like, so if you look at, let's say, any NFT on Ethereum, the asset itself is never on the blockchain. It's just a URL that's on the blockchain, and the asset lives somewhere else, which does not inherit the same security model as the underlying layer one. In this case, what we were talking about is in Ethereum. So what our vision is, like, we see that, okay, a blockchain should be capable of running your entire software stack completely on chain, right? So we are saying, if you want to build the next generation of game or a social media or like a metaverse or DeFi, every aspect of what you do can and should be living on chain. And we already have like lots and lots of applications that have been developed, which are essentially like leveraging the internet computer infrastructure into that. So let's take an example. Let's say if you're trying to build a decentralized version of Twitter, what we are saying is all of the user, like the entire user feed, all the comments, all the videos, all the pictures, every interaction that you do is essentially like built on smart contracts, completely on chain. So if you, let's say in this kind of a Twitter, if you like something, retweet or comment something, each of them is essentially an update call. It's like a smart contract interaction that you do, which updates the state of the blockchain. So that's the big idea here, is like, can you leverage a blockchain to build an end-to-end systems completely on chain? Yeah, and I'm now, why is that very important and critical? If you think about like the promise of decentralization, and everybody has been talking about it, but I just ask a very simple question, right? So when you say XYZ application is built on this blockchain, like I said, the only thing that is on the blockchain is just the token or the ledger of tokens. But somebody, some like trusted person is using their credit card to pay for that Amazon Web Services or Google Cloud, and that is the weakest point in the entire thing, right? So if let's say if I'm running such a service on the blockchain and I just take my credit card away from that AWS account and say, okay, I would not pay for this application anymore, it's basically like there would be no application. It just disappears, the game, the application. So that's the fundamental risk that we're talking about, that if you want to build a completely decentralized application, it has to be done on chain, so that anybody who holds like the DAO that could govern such an application is truly decentralized.
Wow, that's interesting. So how do you achieve that? Like, from the architectural standpoint, like, are you hosting the entire application on ICP? And if so, then I can imagine like running the storage and the backend on ICP should cost like $1 million to run, right?
Yeah, so like, I mean, and most of people don't know that, but let's say to cost even like a phone photo on something like Ethereum is probably going to cost you $800,000 to $1 million, just like this. And it's like, it's pretty practical. Now, why does that happen, right? So because if you think Ethereum is like is a machine where like the same data essentially is replicated. So let's say if there are 100,000 validators running like that Ethereum client, what that would mean is that the same data is essentially replicated 100,000 times over, right? So, which means if you try to upload a photo on Ethereum, it's going to be replicated several times over, and hence the cost.
Right.
When we think about like how we design like the internet computer blockchain, I mean, I'm a part of DFinity, which is one of the major contributors of the internet computer blockchain, or ICP. So what we when we were thinking about this problem, we said, okay, we need a fundamentally different architecture if you want to leverage blockchain to run software. So we made a couple of design choices. First of all, we said all the nodes that are like going to be hosting these like applications and so on, they are all running by independent parties spread over the globe. So if you want to be a node provider, you can just submit a what was that?
Is it for sure?
Mm-hmm. You can just submit a proposal to you can submit a proposal to a DAO that essentially governs the Internet Computer Protocol. So there are a couple of things that you need to do when you submit that proposal. you need to find a data center in your like local geography where these nodes could run. So I'll tell you why in a second. So first of all, you need a data center, and second, you need to identify yourself to the protocol. So you will say that, okay, this is Ian, this is where I would be hosting the node. So they are essentially known entities to the DAO when you apply for that. Now, why do we make those why these decisions, right? So first of all is like we wanted that so in order for you to run like a complete software, you need to ensure that from an end user perspective, there is no difference when they're trying to interact with a Web2 service or a Web3 service. Otherwise, they would just like, if it's too slow, the finality takes 10 minutes, imagine you try to like something on Twitter and it takes you 7 minutes to do that. So it's just impossible, right? So given when the nodes are running out of the data centers, we can ensure that there is like a very strong like gigabytes per second kind of bandwidth that's available to the smart contracts of people that are writing these applications. And the second thing is like because these machines are geographically distributed and these entities are identifying themselves, we can do a deterministic decentralization. We can ensure that this node is actually running out of this data center operated by this entity in UAE. This other node is working out of like a data center in like South Africa or in Asia or in different parts. And then the way internet computer works is we essentially like think of it as like a sharded blockchain. So we essentially say that each of the shards, or in our world we call them as subnets. Each of the so internet computer blockchain is essentially comprised of these different subnets. Where what's very unique and different about our subnets versus like some others that they promote. So if you want to have a service that's running on one subnet, you can essentially call something else on a different subnet. It's just a simple function call. So it all kind of adds up. So you can essentially build a service which lives in like 7 different subnets, and they can just like think of it as like a microservice kind of an architecture. You can just keep on calling any other service to create this dApp that you're trying to build. So that's basically the conceptual idea. So yes, we have data centers running these nodes. Hence, we can ensure that there's very high throughput. We also do deterministic decentralization, which means we don't need to replicate the same data hundreds of thousands of times over. We operate this sharded state, which we call as subnets, and then you can you can horizontally scale the blockchain as much as you want by just keep on adding more and more subnets.
Curious how many data centers we've got right now.
So we have about 75 independent node operators, as far as I can tell. And let me just tell you the latest in terms of the data centers that we have. Yeah, we have 72 data centers through which different nodes are operating out of.
Cool. So what is the revenue model for them? How do they make money?
So say you want to run a node. So essentially you would like apply to this DAO, which says, okay, I want to run a node in this part of the world. When you get approved, you are essentially paid like a flat monthly dollar value paid in ICP. So essentially the network, then the ICP protocol, it essentially mints new ICP to pay for the node providers as their reward. So if you want to say run a node in Dubai, and say you are trying to run a single node, then once you provision your node to the protocol, then the protocol will pay you a certain number of ICPs every month for that. So it's distributed by the protocol, and this number is essentially, so the number of ICP you receive changes every month because the goal for the protocol is to give you a flat dollar amount every month for the node that you're hosting.
Okay, so that's the inflationary aspect of the token, and then the revenue generation part that creates the token demand would be running applications on in these data centers, right?
Yeah. So there are a couple of major contributors to on the inflation side. One is this, like as the rewards are paid to the node providers, and second is like, so the internet computer is essentially governed by a DAO. We call it as NNS, or the network nervous system. So let's say if you have ICP, you can pledge those ICP to receive voting power. So you can essentially stake them to receive voting power. And so you vote on different proposals. So you contribute to the governance of the DAO, and you receive rewards for that. For that, there is like, there is a fixed inflation every year, which basically over 8 years, it kind of drops down to about 5% inflation. So these are the factors that cause inflation. And from a deflation perspective, if you make any transaction, then the transaction fee is burnt. So that's one. The second is like, as you mentioned, the biggest chunk is going to be that with all the different developer activities, they pay for their computation storage using so without introducing a new term, so you essentially pay for this computation and storage by burning, like effectively burning ICP. So that's the deflation.
I see. Okay, so the very first and foremost differentiating point for ICP is that it is the end-to-end decentralized blockchain versus many others that are just the ledgers that they're decentralized and everything else runs on the centralized servers. So I understand ICP is almost like a hosting infrastructure for you to run your decentralized app that would be really decentralized in its entirety. So then what use cases does this bring us?
Yeah, so I'll tell you like some of the things that people are kind of building on the ICP, and we had our so imagine, let's say, if you're trying to build a chat application, right? So or a social network, right? So everybody now, like if you think about the incumbents here in the Web 2, so whether it's like WhatsApp or Facebook Messenger and or in a social network, if you have like Twitter and Facebook and all of these kind of things. Now, the biggest challenge with that is like, someone in those companies today gets to keep like do all the shots, right? So if look at the case of Twitter now, Elon Musk is now calling the shots. Back in the day, someone else was. They get to decide whether to allow the president of the United States to be on the platform or not. And again, these are decisions that are made by a few select individuals in a central setup, right? So the premise for building these decentralized applications is like, could you create an application where there is no central party that's essentially calling the shots, right? So imagine, let's say you want to build this chat application, something like similar to, let's say, WhatsApp. You could then say, okay, I would essentially build this application on this decentralized stack. I would tokenize the application where the founders get to keep like a small percentage of the total supply, and the rest of it is distributed to the users of the platform. So let's say if I create a group or I send chat messages to my friends, I could be airdrop these tokens, and I can then use those tokens to essentially stake and like earn voting rights in like the governance of the platform itself. So there's not, the founders are no longer in control. It's the community that like or the users and other stakeholders who collectively come together and vote on proposals on what should be the evolution, which feature should we be building next. If there is like a geographical aspect to it, then which geography should we be launching, so on and so forth. So like running that kind of a thing end to end is very critical, because otherwise, like I said in my earlier example, if you're doing this entire application, this WhatsApp kind of an application on Amazon or Google Cloud, then first of all, it's the founder whose credit card is the sole deciding factor of who gets to control the application. If they don't like the proposal, they can just pull their credit card out. In this new world, on what I'm talking about on the internet computer, nobody can stop the application. It's governed by a DAO. It's all smart contracts. Anybody in the world can essentially submit a proposal with even a code change, and if the community adopts to that, as soon as the proposal is accepted, it will trigger a code change and update the application. So this is a thing we are calling a service nervous system. So it's like the internet computer is governed by a dog called network nervous system. This one, SNS, is like, think of it as like the thing, the DAO that governs the entire application. So one of our first applications was launched in March of this year. So this one is actually a chat application called OpenChat. And so people who were using that chat application did receive or are about to receive a handsome airdrops, and as well as, like, I mean, as you continue to use this application, you will see more and more benefits in the form of like governance rights and airdrops.
Interesting. So we've got this this open chat application, for example, which is like fully decentralized. What about the domain, though? Isn't it decentralized? Domain name? Somebody has paid for the domain name.
Yeah. So basically, like, so first of all, what you could do is, like, you can essentially have like a custom domain. So like there are two ways in which you can essentially access this application. You can have a canister URL as the domain name, as well as you can do like a custom domain name on the IC. Yes, there are some aspects of those things which, like, we need to like figure out as a part of, like, so like the DNS and all of those things. They need to be decentralized in due course of time. But you can totally kind of look at like this as like a step-by-step process on what needs to be kind of taken care of. So we are thinking about, okay, could there be like a top level domain that all of these teams could use, where you are saying less and less trust on individuals.
Interesting. Well, this conversation is just making me more and more excited, just because it's a true rabbit hole that is like seems to give quite deep. So let's think. Canisters. Why don't we talk about them for a little bit? Like, what can they do? What are these beasts?
Yeah. So we essentially call our smart contracts as canisters, and they are very, like, so think of them as like a very advanced form of a smart contract, and I'll explain why. So in a canister, so like an easy way to think about it is like, think of it as like a Docker or a container, where you can essentially host the code and the state. So the blockchain obviously has the state, and then you can essentially have the code. In canisters, you essentially have like you have a heap memory as well as a stable memory where you can essentially store data as well. So you can store things that are needed for your program. So basically, if you want to imagine, let's say you are in this chat application, OpenChat, that I was talking about, and if you have essentially all your chat messages, all the groups that you've created, people are sharing videos and photos, all of this is in memory. So you essentially have an ability to modify, forward. You want to change, want to change the image and apply filters, right? So now this image is available for to the smart contracts to manipulate, right? So you can change, apply filter, do all those kind of things because this is stored in the memory and it's available for a programmatic use case. If something like this was, if something like this was on something like IPFS, then that's just not possible, because that's more like a cold store, which like if you want to apply a filter to an image, it's just not like possible. It would need to have some intermediary service in between, which will fetch like that image from IPFS, probably some centralized cloud, then would be available. And it's just not going to be practical because of latency or whatever that, and you wouldn't require centralized intermediary. So now you can have an application which is basically like manipulatable by like a program. So coming back to when I was saying what is canister, so canister essentially is a smart contract which can store code and state. You have a heap memory for storing all the things that you need in memory. You also have stable storage where you can essentially store all your assets, images, videos, what have you. And the other thing that's very interesting is it can serve an HTTP request directly. So you can essentially open up your browser and you can just say, okay, hey, canister, show me what you got, and you will be able to interact with smart contracts just simply using a browser.
Interesting. What else can canister do, or what can it hold in it?
It can hold basically anything that you can think of. So all your assets. So it could be images, like videos, of course, code. So I'll give you some examples, right? So people are storing all the things that they're building. They're storing all of their assets in the canister. So they're storing all that data. So if you're talking about an NFT, of course, in our world, NFTs are all stored on chain. They're all in the canister. What we have seen some people do very interesting things is so they have built complete streaming applications. So imagine, let's say you have lots of different canisters. You can orchestrate. So say you have 50 canisters, right? You can orchestrate between them. It's okay, hey, canister one, serve me the first chunk of this information, and you combine that with the second chunk from the second canister and third chunk, and you can essentially very easily create a essentially a streaming of real-time live streaming of 4K video or what have you. So these are the kind of things that canister is able to do, and it can serve that information.
That's interesting. Does this explain how you were able to create the Bitcoin on ICP?
Yeah, so that's a very interesting beast altogether. So, and again, leveraging all of the things that we spoke about. So one of the very interesting things about hey, are you still there?
Yeah, I'm here. Yeah.
Yeah. So one of the very interesting things about hello. Hey, I think I lost you. You still there?
I think I'm back. Yeah.
Okay. Awesome. Cool. So one of the so I was talking about the Bitcoin and integration and so on. So one of the interesting things that we did recently was essentially leveraging all of these capabilities of canisters and smart contracts I was talking about. Is we said, okay, how about we do this to essentially integrate with other chains. So what you need, so let's say, so we just rolled out our Bitcoin integration recently. So in this case, what we did was we essentially need to do a couple of things. So the canisters, which are essentially our smart contracts, they need access to the entire Bitcoin state. Basically, they need to know which accounts has how much balance. So what we did was we essentially fetched all the Bitcoin state and constantly doing that. And we can essentially
hold on a sec. So did you deploy the series of oracles to watch the Bitcoin price and transactions, the entire network?
Yeah. So okay. So one thing I need to mention also about canisters, which is very interesting, is canisters can essentially make HTTP out calls. So they essentially have a power to actually connect with any Web2 service. So we don't need any central oracle. If you want to fetch the price of an asset, you just need to make a call to an external Web2 service and you can fetch that. So the canisters are capable of making HTTP out calls.
Wow. I was just on another call with my dev team, and we are building something for the Ethereum based chains. I think it's Polygon or something, and they've got so many issues with Chainlink as an oracle, because it's not native to the concept of Ethereum itself, right?
Yeah, because if you think about any standard blockchain, right? So blockchain is a an ecosystem, a silo in itself. And if you want an external service to interact with the blockchain, you need these things called oracles, which essentially are like, how do you get data into this blockchain? So that's why you need like so if you want two blockchains to talk, or if you want to, let's say, in a DeFi system, you want to fetch the price of an asset, then you use like things like Chainlink and so on. In our world, you because the canisters can directly make HTTP out calls, you can essentially like connect with any other service. In the, say, you could basically ping Coinbase and Binance and like somewhere else to basically fetch 3 different prices for BTC, ICP pair, bring them on chain, and then you can essentially like apply a transform function, which is like, you can say, okay, as long as these prices are within that like 2 basis points range, then I'm fine accepting this price. So it's kind of similar stuff what Chainlink does as an independent party. We are saying, okay, this can be done by any smart contract developer on the internet computer, so on. So yeah, I think, so coming back to that Bitcoin integration thing, so what we said is like, what we need is an ability to do 2 things. We need to essentially read the state of the blockchain. So we basically pull the entire Bitcoin blockchain, and then we extracted all the unspent transaction outputs. So which, for us, what matters is like, how much is the account balance, or in Bitcoin terms, it's the unspent transaction output, UTXOs. How much is the balance in each of these different addresses, and we essentially keep a state of that. And so we have an adapter that just keeps on fetching that Bitcoin state and always makes it like available in the form of available to any smart contract or any canister on the internet computer. So this first integration was done at the replica level. So think of it as like our client equivalent. So we fetched all the Bitcoin state. We store all the UTXOs, and because our canisters can hold like I believe now 50 some gigabytes of data. So this data is essentially there with the entire Bitcoin state available. So that's the first thing. The second thing, which we spent about 20 months building, is another very cool thing, which leverages our existing, we call it as chain key technology. So at a high level, what we did in this case was we essentially implemented the signature scheme of how you sign a Bitcoin transaction. So that's like the ECDSA. We implemented a threshold version of that. So the idea is like, so once you know what is how much balance each of the like Bitcoin addresses has, the second thing you need to do is you need to be able to sign a Bitcoin transaction. Now, to sign a Bitcoin transaction, so typically, let's say you can use a Bitcoin wallet to sign a transaction, but you need a private key. So in this replicated state, we cannot essentially have a private key. We cannot trust anyone with a private key. So what we do is we implemented this mechanism in which no one party has any access to the private key, and we create shares of this private key, and we share it with different nodes that are running that subnet. So we use things like Shamir secret sharing, where we essentially, a part of the key is distributed across all of these different nodes. In this case, there are about 28 nodes that are basically, and then a subset of them come together to create a threshold number of them come together to create a signature using that like shared like secret.
To create a signature, but can they conspire though and be like, hey, let's
yeah, so basically so I'll come to that in a second, right? So now the idea is like, you can read, how much balance each of the address has, and now you have an ability to create a signature where X number of them come together, and then you can essentially sign a Bitcoin transaction. So what that enables is the canister smart contracts can have a Bitcoin address. You can send a Bitcoin to them directly. You don't need any wrapping or anything in between. Just each smart contract has a Bitcoin address. Ian says, send me a Bitcoin at this address. That goes to the canister, and the canister can, like on Ian's behalf, sign a transaction. So if you want to build the entire Bitcoin, DeFi, all that, that's all possible.
So the canister itself is like is like a service, but it can also be an address. So it can act as an address, signing the transactions with all the magic under the bonnet. Is that correct?
Mm-hmm. Yeah.
Wow.
So basically, yeah, once we implemented this like signature model, so all you need is like a public key to send Bitcoin to, and then you already have this X number of nodes coming together to sign that transaction. So you can essentially move Bitcoin around. So we did this integration. There's no intermediary in between. The only thing that you need to trust on is obviously the Bitcoin network, which you do. And then you trust on the ICP blockchain, but there is nothing in between. There is no third party which is creating this wrapping of Bitcoin or REN, BTC, all of these things. You don't need any of that. There's just direct communication between two blockchains.
Oh, right. How about other chains and other signature, like signature schemas?
Yeah, so the next one that we are coming, like launching hopefully very soon. The first version is like community is helping us build. So we're going to be integrating with Ethereum, and that should enable us with basically any Ethereum compatible like layer 2 as well. So all of the different, the Polygons, Arbitrum, Optimisms of the world, and so on. So that should be basically all integrated because it's the same signature scheme. They also use ECDSA, interestingly. So that's what we are working on. So so we already solved the signature signing piece. What we are now doing is like our community is helping us in the first version, phase 1. They'll be essentially making HTTP out calls, which is the fact that you can ping any service. They'll be making HTTP out calls to all the Ethereum RPC providers like Alchemy, Infura, QuickNode, all of those. Pull all the Ethereum kind of relevant state, and then you already have an ability to sign a transaction. In phase 2, we will essentially be running our own Ethereum nodes, which will be working very closely in sync proximity to our own nodes. When I say we, that I mean the protocol, and you essentially would have an ability to basically have a fully decentralized Ethereum integration where we don't need to partner with Ethereum or any of these chains to make that happen. It just like works.
That's interesting. Did you compare yourself to the interoperability protocols then, like companies like Layer 0? And if yes, what are your competitive advantages?
Yeah, so there is a couple of like obviously Layer 0 is doing some interesting stuff. There is like, for example, Cosmos, which has this IBC communication protocol where they're trying to basically build these bridges. There is some aspect of this stuff that even Polkadot is trying to do. I think what our approach is like just the simplicity of it, right? So the fact that you can essentially just simply make a out call to these like basically these chains fetch the data and you have an ability to sign. You don't need anything in between. So for example, if you on the other hand, like for a lot of these other players, the problem is that they need some support from the other chains to pull out their integration. So you need that aspect to be supported by the Bitcoin is not going to support anything as you know, right? And we have a working implementation of Bitcoin where you can today it's live in Canister. You can just send a Bitcoin directly, and you can like maybe deposit money in a lending protocol and start earning yield on Bitcoin. So that application is coming pretty soon. It's being built by one of the community developer, but that's the use case. So you can send Bitcoin today into these applications and just see it work. Yeah, I had promised you. Sorry, I had to just finish that. I had promised you like the attack or the risk surface as you were asking about that. So basically the key idea is like we have essentially currently it's on a 28 node subnet where like all of these shares or signature shares, secret shares are kind of shared. Out of that, 10 out of the 28 nodes need to come together. That's the current threshold that it's working on. They need to come and create a signature. Now you can obviously keep on increasing the number of nodes. The downside of that is going to be that the more nodes you have, the slower it's going to be for enough parties to come together to compute a signature. So it might take like multiple seconds to actually create a signature. And again, that's a path. If like as maybe there is more and more value in the ecosystem, that's a path the community, the internet computer community may feel that, okay, that's what we need to do. We need to keep on adding more and more nodes. But you can, so that your security threshold keeps on increasing.
Or have any kind of like the application level staking then for these node holders to ensure, you know, the validity of the transaction, as in they would be slashed if they did any bad acting.
Yeah, so we have a bunch of checks in place, right? So first of all, you need to have let's say more than a third of nodes to collaborate together to kind of try to collude.
Mm-hmm.
Now the other thing is we also do a lot of this secret shuffling, right? So we keep on resharing that to different parties. So it's not that. So for example, if you have one share, in like it's not that it's going to be staying the same. So we keep on like providing you with a different thing. So, for example, if I try to collide, like get these people to collaborate, if I get 5 of them, maybe the entire thing would be irrelevant by the time I reach to the 6th guy because all those secrets have been reshared. So that's one. The second thing is like it's also important to understand that all of these node providers are known entities. Known in terms of like they have provided that, okay, I'm Ian and I'm running this node to the network. So they are also like, it's not that they can I mean, they're also accountable by law to if they try to kind of gamify the system. And third, we are also working on a lot of interesting things. So basically hardware level encryption, SCP, SMP, and stuff like that, which would further solidify all of these things where the node providers wouldn't have access to basically, because the information would be hardware encrypted. So even if they try to stick around and do stuff, it's just not going to be possible for them to pull it off. So they have to pull out something in a very short span of time, like across different geographies. And we think at this stage, it's not going to be practical.
That's very interesting. So far, this is the most interesting layer 1 solution I've ever heard of. And of course, I'm not new to it. That's what has been keeping me excited about ICP for more than a year now. All right. Well, enough about the solution itself. Why don't we talk a little bit about the ecosystem and you as someone in charge of the growth of the ecosystem, what are your challenges and hurdles, and what help do you need from the ecosystem, from the venture capital community?
Yeah, I think so. I'll give a kind of perspective on where we stand today. So one of the interesting things is like so we launched back in May of 2021. So it's almost coming up to kind of 2-year anniversary for the mainnet launch. So we were, I think, one of the, except for I would say Aptos and Sui, which are the recent entrants, most of the chains have been kind of building for quite some time. So we are relatively newest entrant in the game. So, but I think what's very interesting and for us is like if you look at like lots of people do these charts on the developer activity, it's Electric Capital, and then there's a proof of GitHub, and then there's like Coin, Crypto, Miso, and all of these metrics. So if you look at the activity, you will see that actually ICP has amongst the highest number of GitHub commits by the ecosystem and so on and so forth. So like what we are seeing, I mean, is like we have lots of interesting activity from developers where people are trying to build, they're experimenting with a lot of different things because a lot of things are just possible here. They're trying to build like a Web3 search engine. They're trying to build a decentralized version of GitHub. They're trying to build, of course, that's like the DeFi stack, which they're trying to reimagine. Okay, how would it work in a multi-chain setting where you can you can have ability to bring in Bitcoin?
Look, I've just thought of a crazy idea myself, because ChatGPT may steal so many jobs from humans. What if we tokenized a next AI platform and gave the tokens to like the entire Earth population, so everybody would be benefiting from a system that may have potentially like stolen their jobs, but they will have the passive income from holding a part of it. Wouldn't it be cool?
Sounds very interesting. So I think it's extending that universal basic income kind of a model even further to like a global setting. So yeah, that sounds pretty cool.
And do you think like so really AI it's how I came to crypto. I've been into AI in 2016, 17, and I definitely saw back there how AI would take over human jobs in 10 to 20 years from then. So the clock is ticking for sure. And I envisaged the future where the businesses would be autonomous and the like humans would not necessarily need to work inside the businesses, but to really just be the architects of businesses using the AI for everything else, like all the task automation and stuff. Something that is happening today. And I thought, well, all right, if businesses have to run autonomously, like what would be this perfect execution environment for them to really persist in that way? And that's how I stumbled upon Ethereum. Yeah, and because, like, of course, C++ being my first language I worked with as a developer, like back 2 decades ago, I was like, what? Like Ethereum is definitely like, or like the smart contracts is the future for not only DeFi but businesses overall. So now I'm trying to see how blockchain can really host AI so that AI can become decentralized as well. Is ICP a good platform for that?
Yeah, I think if you think about like, so there are multiple layers to AI, right? So one is if you even if you just like look at a simple construct of like how are these models getting trained, um, like in the first place, where is all this data, like, and all of these models getting stored? Is that still with a like the centralized entity which can continue to kind of manipulate, or basically, I mean, if there is a bias that is getting introduced, you don't even know, right? And you will run into very similar problems that you are seeing with the traditional like Web2 services like Twitter and so on. Because yeah, as these algorithms keep on getting smarter and smarter, there is obviously a human element in terms of which was originally involved in training these data sets and what information was fed and so on and so forth. So what I believe the blockchain has a power to do is a lot of things, right? So it can be like, okay, how do you ensure that the data that's basically being leveraged for these like training models and the models itself can be available for anybody and everybody on a blockchain? And I don't know of any other blockchain, honestly, which can store all this kind of data, which is available or on chain. Like this is very much very possible on ICP, because from our point of view, it's basically storage and like a programmable storage where you can, if you build an model, you update the model, you can just basically push an update, and that like maybe the community can step in to like propose changes on, okay, how maybe this is a new data set on which this model needs to be retrained, and those kind of use cases could be very much possible. Plus, of course, as you said, I mean, like you want to tokenize this entire information or this entire model, the data infrastructure. Everybody who's providing a data maybe have a token, and they get to decide how these models needs to be trained in the future, and who gets to keep a piece of the pie. So all that is possible, I think.
This is very dope. Well, anyhow, all right. So let's get back to your hurdles and where you need help.
No, I think so. What I will say is like lots of activity in the ecosystem for sure. We have, I think, the way our teams are kind of. So we have lots of teams who have built very interesting products. So you can essentially go to internetcomputer.org/ecosystem, and you can check out some of these products. You can play with them. So you can see all of this is real, being served from chain. So we're not talking about anything hypothetical. Like I said, these social networks are live, these chats are live.
Yeah, because you guys took 5 years to build or something, right? 5 years.
Yeah, and now it's like all of these entrepreneurs that are coming to build on top of the internet computer. That's really the next wave, right? And these people will show the world on what is possible on the internet computer. What the support we need, of course, from the community is like, yeah, we want more and more participants, whether as users who essentially like take out this vision of let's build a decentralized version of the internet. So we want more users to come in and essentially start using some of these services. We of course want communities to come and participate as these projects are trying to do like basically do decentralization sales. I mean, we could have investors. I mean, they could be VCs or even just like regular people who can say, okay, I want to be a part of this mission and I want to be contributing to the cause. So I think that's the kind of things that we need more and more. Of course, as any other ecosystem, that's what we need to.
It all makes me so excited. I literally want to just like cancel all my LP meetings and be like, and ask my PA to be like, hey, we are so sorry. Ian is working on like, building the future of the globe with ICP. So don't bother him with your calls and stuff like that.
Yeah, that'll be awesome. Thank you.
No, really, ICP is. Well, I'll be honest. Like, I first didn't get like the full depth of it. I was like, yeah, it's an interesting concept. It's definitely unlike anything else, but really, it's like a good wine. It unfolds over time, and I think I'm enlightened now. I kind of took the right pill.
Yeah, that's so cool. Yeah, I mean, I think, and I agree with you. I mean, I think there's like so many different layers, right? So, because it's like I mean, we think of it as like a very paradigm shift from like how people's current mental models are. So, as you said, like in a few minutes, we try to cover everything from, okay, we forgot about this HTTP out calls, which is like something that you need. And now, as we got into this Bitcoin Ethereum integration to like the stuff that's possible, even with things like AI, the thing is like internet computer essentially enables all of these things and makes it very possible. And so when you're talking to someone, you can only in a few minutes, you can only give them like a small piece to just like take them from their current model for this. But this is a very great conversation, and thanks for, because you had such an awesome background when understanding different blockchains, and you have some context that I see. So I think it's good to have this conversation and share with you like different perspectives about the ICP.
Yeah, and so you see, we've been discussing many things, including like the sovereign funds and stuff. And the thing with the sovereigns is they are chasing after like very like large problems because they have large checks. Yeah, and I think like how ICP can solve the challenges of the future nationwide, like for many nations, is making ICP very suitable for being presented in front of like the the most powerful investment groups on earth. So it's very interesting. This conversation itself has been quite refreshing for me, to say the least. I'm also hoping it's the same for many other people who are listening to us.
No, it is certainly a great conversation for me, and I think, like I said, I think at this stage, the key for us is like all of these different entrepreneurs and smart people that are trying to build some very cool stuff on the internet computer. Yeah, we are trying to essentially support them in the best way possible, whether it's through helping them with things like how to build your communities on Web3, which is why I'm inviting more and more people to come and join and play with these products and spread the word. To I think of course like fundraising and like venture building, because at the end of the day you need to think of it as like a startup, and then unless you can get to a point where you can secure a runway and you can build sustainable like products, I think this is the kind of things that we need. And lots of activity in the ecosystem would encourage everyone to go and try.
Cool. Well, thank you for the very interesting conversation. We've spent 55 minutes for this, but really it feels like nothing. We could still chat for hours, right? So probably another conversation in a few months from now is what I'd love to do with you, Lomesh. You've been a great and very interesting speaker to talk about ICP. I would like to thank you and thank the entire audience for chiming in and listening and watching us. And till the next time, see you soon.
Really appreciate your time, and thank you so much, Ian, and thank you for all the listeners. Thanks again. Bye.
Cheers. Bye now.